Hello, my name is Sara Abdollahi. I'm a PhD student in the University of Hanover, and currently I'm doing a research in British Library. My PhD topic is building user access models to event-centric information, and this presentation is about my ongoing research on building event collections from web archives and using knowledge graphs. The world is constantly facing events such as terrorist attacks, Brexit, and the migrant crisis, which have resulted in a large amount of event-centric information on the web. Researchers such as digital humanities researchers and social scientists who analyze the significant events that influence and shape our societies can specifically benefit from web archives that reflect the perception of events during their happening time. Browsing web pages through web archives one by one is time-consuming and needs an additional intensive cleaning phase. So having a collection of web documents about a specific event could facilitate their research. The image in this slide shows some examples of available collections in the British Library web archives. These collections are manually created by the staff in British Library. However, there are some challenges with creating these collections. First is that it's sometimes infeasible due to the high number of related URLs. And second is that the final created collections may not cover all necessary information related to a specific event. Having talked about the challenges of creating the collections manually, we propose an approach to automatically create event collections from web archives using knowledge graphs. This approach has two main components. The first one is that we leverage information in knowledge graphs to collect related information and expand the user's query, which is an event in this research. And second one is that we rank initial web documents to select top related ones as the final collection. As shown in this figure here, we collect initial set of web documents from web archives, mainly using keyword search in available web archive interfaces. And then using a re-ranking method, we rank them based on the expanded queries. As mentioned previously, knowledge graphs are one of the main resources in this research. Knowledge graphs are collections of interlinked real-world entities and concepts. This is a small example here, shows the relation between two entities, A and B. Some of the most popular knowledge graphs are Google Knowledge Graph, which is used in Google search engine, DBpedia and Wikidata, which are public knowledge graphs constructed based on Wikipedia, and EventKG, which is a public multilingual event-centric knowledge graph that represents information about events. Knowledge graphs are used in many fields these days, such as semantic search and recommendation. In this slide, I have prepared an example of how information are represented in knowledge graphs. This figure shows British Library and some of its features and relations in Wikidata knowledge graph. As shown in this image, many useful information such as location, directors, website, country, and other connected organizations are easily accessible through knowledge graphs. Let me show another example of events and how the related information are presented in EventKG knowledge graph. In this example, the main event is Arab Spring, and using has place and sub-events relations, we could find Tunisia and Egypt as two of the locations and Tunisian Revolution as one of the sub-events of this event. The main idea behind using event-centric information from EventKG knowledge graph is to expand the initial user query, which is an event in this research. In this slide, I show how using Sparkle, which is a query language used in knowledge graphs, I get all sub-events of Arab Spring from EventKG. The table in the right side shows some of these sub-events. And in this example, I use a Sparkle query to extract all the locations that Arab Spring has happened. After collecting all related information to a given event, we rank them to choose the most related ones. There are some approaches to rank this related information, such as using number of their relations in knowledge graphs, or number of times these two entities are mentioned in Wikipedia sentences. Let's take Arab Spring as an example again. Some of the top selected entities from Event KG related to Arab Spring are Yemeni Revolution, Tunisian Revolution, Algerian protests as sub-events, and Tunisia, Egypt, and Middle East as locations of Arab Spring. Then we expand the main query, Arab Spring, using these related entities. These are some of the expanded queries. Like the first one is Arab Spring and Yemeni Revolution, second one Arab Spring and Tunisian Revolution, and third one Arab Spring and Middle East. Coming to the final step, we use a re-ranking method to rank results of all expanded queries. We use BERT, which is a state-of-the-art method for document retrieval. BERT is a language model which has an understanding of human language by learning representation of words in a text. It has many applications such as text summarization, next word prediction, and document ranking. And finally, I'd like to show a simple example of how all these steps work. For this example, I have used New York Times collection. And let's say that we want to create collections for 1988 Summer Olympics. After extracting related information to this event from Event KG Knowledge Graph and ranking them, we construct some of queries, one of which is 1988 Summer Olympics, Seoul, South Korea, Kirsten Otto, Matbiyandi, which consists of related locations and people to the main event. Following are the titles of the top 3 web documents from New York Times collection for the mentioned expanded query. The first one is familiar names are lighting up results board. The second one is Ivan and Biyandi win gold again. And the third one is that Otto of East Germany takes 4th gold. This example shows a simple version of our approach. In fact, we create many new queries and rank their results, and we try to cover all related information to an event as much as possible. This was my presentation about building event collections from Web Archives, and thank you for your attention.